And welcome everybody to the Daily Space Weather. Today we'll be talking about a solar downtick, cosmology segment, MANSA, a sunspot analysis. So congrats on finding the existence of our channel. Here's the sun and ionized helium from the Solar Dynamics Observatory. We've got degrading sunspots across the board. And now that we've showed you time and date stamps, let's zoom in a little bit here to show all the active regions. There we go. Quite a few active regions here. Likelihood of major solar flares has dropped a little bit. There is still some possibility for some minor coronal mass ejections to happen. No major watches or warnings currently in effect. Here's a colorized magnetogram. And again, pretty much all sunspot groups have degraded here. And you can see from the colorized magnetogram some of that. This is the same period, by the way. That's all 1 day's worth of data. There you go. There's time and date stamps. And here is the intensity gram. And we'll zoom in a little bit here to show all the sunspot groups. I think we're still going to have 5 named groups here. At least 4 named groups by the end of the day today. Some may lose beta classification. Again, they've pretty much all degraded here. The radio flux has also dipped. We'll get to it in a moment. So there's your solar intensity gram from the SDO. Here's a diagram of the solar system. There's where things will be in 1 week. Full moon coming tomorrow. Expect people to sleep worse. Probably the reason people think lunatics are a thing. So radio flux has dipped down to 89. The upper chromosphere and lower corona of the sun emit radio frequency, and it's the most proportional data set that there is to the sunspot number. Discovered in 1947 by Canadian radio operators. The 10.7 centimeter radio flux is expressed in solar flux units, which coincide with 10,000 joules. There's the 1-year chart of the radio flux. It's this black line, and you can see how proportional it is to this line underneath. A little bit of a discontinuity here, actually, as we saw the sunspot number jump way up, and the radio flux kind of only got to 94, and then it dropped back down to 89. So Space Weather Enthusiast dashboard telling us to expect some geomagnetic unrest here. Let me just press refresh and make sure we're looking at the most current data. Now it's showing 94 solar flux units. Anyway, the last update I saw showed 89 solar flux units. Anyway, expecting geomagnetic storms here from an expected glancing blow from a coronal mass ejection late in the day today. Between 1800 and 2100, the onset of the coronal mass ejection glancing blow expected according to NOAA. I'm not sure if I agree. I won't argue. I'll just move on to talk about seismicity. Long story short, earthquake droughts end in major earthquakes. We haven't seen a 7 magnitude earthquake since May. It's a massive earthquake drought. Let's see what's on the list. One coming in as we did the show here. And let's just scroll up the list and see what we've got. And if we leave anything out, just leave us a comment and let us know. We do read all of our comments, and thanks for everybody who has commented. Thanks to our new viewers, especially. So some 5 magnitude quakes here. There is one extremely far north that's actually off the map. That one up there in between Svalbard and Greenland, close to the net North Pole. It was over a 5 magnitude. Anyway, basically a lull in earthquakes here. Only a few in the 5 magnitude range, such as this 5.2 at Papua New Guinea that came in at 6:16 universal time. Continuing on to volcanoes. Looks like a downtick in volcanoes. Karimsky is still erupting in an explosive fashion and producing a 10,000-foot plume of volcanic ash over the Kamchatka Peninsula. Suminosejima, unknown ash cloud there. Please do not pole vault the caldera. I implore you, please do not pole vault the caldera. We need the views on YouTube. Dacono also erupting and producing a 7,000-foot plume of volcanic ash. Fuego exploding, 16,000-foot ash plume over Guatemala. And Sabancaya also exploding, 24,000-foot ash plume over Peru. A reminder not to pole vault the caldera. It could be unfortunate and unhealthful. So we implore you, please do not pole vault the caldera. And if you see the pattern of nonsense, then leave us a comment. Let us know. Let us know what your favorite nonsense videos are. Are they see the pattern, or I won't mention any other nonsensical YouTube channels. I'll leave them unnamed, as they don't need any free advertising. Next, looking at the GOES 16 sun-facing suite of instruments, starting with the X-ray flux. No major flares here over the past couple of days. That's a 3-day chart. Surprisingly low amount of flaring there. We were expecting some more flares, didn't really get them. The fields associated with the sunspots were appropriate for major flares. It just didn't happen. Here's the proton flux over the past 3 days. Let's bring this to a 1-day chart. It looks like there's missing data. All right. Yeah, there's some missing data there. There's the 1-day chart. No spikes on the proton flux. No coronal mass ejections have made it to the GOES 16 yet. Here's the magnetometer readings, and you can see these spiky patterns showing up here. It's because there's a little bit of an indecision, a tug of war, magnetically speaking, going on in the heliospheric current sheet, which we'll show you here in a moment. The South Pole-oriented current sheet can't make up its mind if it wants to arrive or not, and so there's a magnetic battle happening just in front of the Earth. So out here between Earth and stereo A, there is a little bit of indecision going on with the polarity of the current sheet, as you can see right there. North Pole current sheet shown in green, South Pole shown in red, and as the Earth snaps back and forth, we're seeing some increased geomagnetism as a result of that polarity shift. Keep in mind this data, when we shot the video, was 1 hour and 48 minutes old. Here's another view of the same thing from the line of sight perspective. It also shows you the solar magnetogram, and you can see that blue line waving back and forth as solar cycle 25 progresses in terms of its solar polar field reversal process. We're documenting it daily on the channel as we watch the solar polar field shifting. So speaking of the solar polar fields, this blue imagery here, these lines are the sun's B field, which are essentially a net product of the overlap of the two solar polar fields. I won't get into magnetohydrodynamics too much on the daily space weather video. This line of sight coronal hole plot is one of the most important data sets we see, and there is a large, rather poorly defined coronal hole system here from the south. You can see it in red there, stretching beyond the equator. And this data is derived from ground-based magnetometers, as well as magnetometers out on stereo A, which is here, and stereo B, which is here at Lagrange point 4. This is Lagrange point 5. The line of sight coronal hole plot is super important, and we'll have to make another cosmology video about that soon. So the probability of solar flares has gone down a bit with the degradation of these sunspots. There is still a possibility for major flares. We could still see an M-class flare. Don't be surprised to see some. And yeah, so there still is a solar flare watch, but it's not quite as extreme again because those sunspots have degraded over the past 24 since yesterday's daily space weather video. So we did see a brief period of geomagnetic unrest there yesterday around when we made our video. Current conditions are quite calm, KP of 1 over the past 15 hours. And let's take a look at the real-time solar wind. We did see some missing data. It looks like it's been put back on the chart here. There were some oddities showing up in the data. I'm not sure if it was just a display issue. I think it was just a display issue. So this right here looks like a little coronal mass ejection strike right here. This little tiny, barely any signal there. Little tiny uptick and then a downtick in the solar wind density, as well as a downtick in the speed and an uptick in the solar wind temperature. So that looks like a coronal mass ejection strike. And if that's the glancing blow, that is hardly even a signal. In any case, current conditions are Quite a diffuse solar wind here, around 3 protons per cubic centimeter. Solar wind density around 3 protons per cubic centimeter. Solar wind speed only 390 kilometers per second. The solar wind coronal hole high-speed stream has largely subsided here. Now, I do have a comment about the geospace magnetosphere movie. Look at how homogeneous the magnetohydrodynamic pressure is around the planet right now. We have basically no plasmasphere. Usually there's some empty space in here. And we've got high pressure all the way down to the ionosphere level, perhaps. We'll see if that translates into any anomalies. I'm going to let it play through a second time, as that is a pretty anomalous looking magnetosphere to me. What do you, our regular viewers, have to say? And if you're a new viewer, we do show this data daily. It's 4 hours of data from University of Michigan. And the scale here is nanopascals magnetohydrodynamic pressure. And next we'll show you ground magnetic perturbation, since there's a polar excursion going on down here on planet Earth, or wherever you're located. Please leave us a comment if you're viewing from another universe, timeline, solar system, galaxy, spacecraft, etc. Geospace Delta B are changes to Earth's B field. Ground magnetic perturbations are the second geospace magnetosphere movie. Both of these geospace magnetosphere movies are 4 hours of data. They're based on the space weather modeling framework. Nothing too crazy going on there on ground magnetic perturbations. And thanks to our new subscribers, etc. on YouTube. If you're viewing the videos elsewhere, such as on BitChute, make sure you go subscribe on YouTube, as there is a lot of content that you'd be missing. We only upload about 20% of our content onto BitChute. There are some exclusives, so if you only view on YouTube, make sure you check out BitChute. We just recently did a 500 subscriber special. Look for more exclusive content coming there soon. And a quick side note, Fauci committed fraud. When's he going to be held accountable? Are you accountable? Is Fauci accountable? When's he going to be accountable? We've remonetized and re-released our Wednesday stream. It got demonetized right after we did it, so it went to unlisted only for patrons. Now it's back, so make sure you check out our playlists, youtube.com/smashamash/playlists. When is Fauci going to be held accountable? youtube.com/smashamash/playlists includes all kinds of playlists. And again, we've re-released that one. The title is, let me just go to the full playlist here for our weekly Wednesday stream. The title is, Will Fauci Face Accountability, or Do We Live in a Banana Republic? BitChute.com/smashamash. Thanks to our new subscribers over there on BitChute. And look at the views. We've got a new most viewed video here about climate change. Yes, we've been angering people on Facebook who don't watch the videos. They just idiotically comment without even watching the videos. Thanks to our new followers over on Twitch. Twitch.tv/smashamash will actually stream our meteorology segment today to twitch.tv/smashamash. They've got a great mobile app, and Twitch is probably the ultimate live streaming platform. Today's Cosmology segment is integrated into the daily space weather video. Again, check our playlists. There are over 200 Cosmology segments on our YouTube playlist, youtube.com/smashamash/playlists. And here's our brief Cosmology segment. Check it out. This is the astronomy picture of the day, and you can check it out yourself at apod.nasa.gov. It's a couple of nebulae here. These are some Messier objects, I believe. Elephant, bat, and squid. Anyway, this is IC 1396 and SH2-129. Some emission nebulae. It's the astronomy picture of the day. I have no idea what spectra that we're looking at there. That's probably like hydrogen alpha and maybe infrared light. I really don't know. This looks like X-ray up here. So this could be X-ray. I don't know. Often X-ray is shown in blue. So it's not telling us what the spectra that we're seeing there are. But that's the astronomy picture of the day. There's a lot of cosmology information on our forum at smashamash.com/forum. Check it out. There's a whole cosmology forum there. So check that out if you haven't. And welcome to the Neo Renaissance. Visit our own homepage, smashamash.org. We'll redirect you to this page. You can find our social media there, links to our Discord chat, our Patreon, and all kinds of other stuff, like our shops. One of our shops is this one, and if you click on smAsho Store, you'll be directed to this site. Have some style. Are you safe yet? We're wondering here, are you safe yet? Congratulations on surviving a global pandemic so far. Today's featured product is the MANSA shirt, and we implore you to make America not suck again. Now, I'm currently wearing that exact shirt. Check it out. There you go. MANSA. It's completely nonpartisan, and we think you can anger Trump supporters and anti-Trump people with the same product. That's why we bought it, and that's why we created it. MANSA. Make America not suck again, because it's up to you, not the government. Links to that from our homepage. By the way, if you were a Patreon, you may have seen this article, which we're not going to tell you anything about. It's been sent only to top-tier patrons. So if you want to see the top information about that, then become a top-tier patron at the gold or condensed matter to the 9th power level. Today's random object, quote, random object, end quote, is number 433 on the Neil Gorels, which is a low-mass X-ray binary / massive radio source believed to be a neutron star known as H1254-690. And here's some imagery of that, sort of. Here's the infrared spectroscopy of it, and there's not a lot of heat, not a lot of thermal emission coming from this source. Here it is in colored light from the DSS optical survey. And not a lot of data on this one, but we did unearth some papers here about things like magnetic braking, and as well as an onboard catalog of known X-ray sources. You can find all that stuff yourself if you just go to the Neil Gorels and you just click on that object, number 433. There's the X-ray outputs from it. And if you want to see more information on it, just click on Simbad, and then you can find all kinds of other references about that low-mass X-ray binary / massive radio source, number 433 on the Neil Gorels, also known as 4U1254-690. It's a low-mass X-ray binary. Have you heard about Mars? Well, there is a seismograph or two. I'm not sure how many. Can anybody comment how many seismographs are currently on Mars? Anyway, these seismographs are making people more confident that they understand the internal structures of the planet. I don't have a whole lot of commentary on this one. You may want to read the article. This one's in the phys.org Astronomy and Space section. InSight mission, Mars unveiled. So believing that there is a liquid core, maybe similar to the Earth's mantle, perhaps explaining why there is a very weak magnetosphere around planet Mars. I'm just letting the article scroll here so you can read it. Feel free to read it. Pause the video if you like. We'll be here when you unpause. And do you have any theories about the structure of Mars? Do you agree with this? Or do you think there is perhaps some unknown information about the interiors of planets? Is there superionized material down there? Is there a lack of superionized material? Is there some kind of a magnetic shielding happening on Mars? Who knows? That's today's Cosmology segment. Again, it was integrated into today's daily space weather video, and don't forget to check our playlists at youtube.com/smashamash/playlists for lots more, hundreds more Cosmology segments. Let's continue on. And let's talk about electron flux. I was wrong with my forecast yesterday. I was expecting higher levels of electron flux. We don't see any charging hazards. There's the information on that. The relativistic electrons surrounding planet Earth can charge up satellites. They haven't been doing so. Here's the 1-year chart, and we're just in a moderate range here of electron flux. I'm still expecting this to rise a bit, and we're seeing some strangeness in the data here. There we go. There's the 3-day chart of the electron flux, just in a moderate range here, and I would still expect us to go into warning levels pretty soon. I would say the forecast should be more like up here. And the green boxes are the forecast there. The yellow diamonds are the observation. I'm still expecting an increase in the electron flux. since plasma travels like train cars through space, and the connections are the electrons. Anyway, here's a diagram of the atmosphere in terms of Earth's Van Allen belts. Feel free to pause the video. Distance is shown here in miles. And here is the total electron content forecast visualization. A little bit of anomalies happening here. Once again, some anomalies here in the southern Indian Ocean. Not as extreme as yesterday and I believe 3 days ago. And we even featured the total electron content forecast imagery on yesterday's thumbnail because of anomalies here around Antarctica. Once again, some additional miniature Van Allen belts forming down there. Things looking a little more normal here, and this gives you an idea of GPS errors. The closer to red of a color you see, the more likely and the more significant GPS errors will be, as they have to communicate through all those electrons. Here's another diagram of the atmosphere. Distance is shown here in kilometers, as well as thermosphere temperatures, electromagnetic radiation penetration, and atmospheric molecular content. We're looking at the F ionosphere layer next at about 300 kilometers of altitude. Let's give that a minute to reload. And we're seeing anomalies here once again south of the equator. Surprisingly high vibrational regions there, despite it being wintertime in the southern hemisphere. So anomalies happening here just west of the South Atlantic anomaly. So the Earth has two very weak spots in its magnetosphere, one about here, that's the South Atlantic anomaly, and one down here now as it's split into two. We've now got a South African anomaly as well, last I checked. And the ionogram gives us insight into Earth's magnetic field, as the behavior of vibrating molecules up there is indeed the bridge between Earth and space. Perhaps it gives us insight into the inner workings of the Earth. Most likely it does. Let's move on. After looking at the latest image, there's the latest image from 8:15 Universal Time. Looking normal at that moment. So we just did another awesome meteorology segment. If you haven't checked that out, check it out. youtube.com/smashamash/videos or youtube.com/smashamash/playlists. Contain lots of stuff. And here come bonus features, starting with the latest imagery from the L-Tide. Not the L-Tide, the Lermonth. And there's the latest ground-based observatory data from the Lermonth Solar Observatory, located in Lermonth, Australia. And there still is quite a bit of activity going on. There are quite a lot of filaments here. You can see all those dark regions, as well as the bright regions overlap those prominences, as we call them. This is all hydrogen alpha, by the way, 6,562.8 angstroms. Here's more. So there's the latest intensity gram. Here's the latest colorized magnetogram. And again, you can see these sunspots have degraded here. That one's gone entirely. That one there is setting. That's going to lose its name as well. That is only alpha class. That is alpha class. And that's degrading promptly. So a significant downtick here in solar activity. The likelihood of solar flares has gone down. And with it, the likelihood of coronal mass ejections has gone down a bit as well. Here is the GOES 16 SUVI thematic map. We call them like we see them, and the day we stop is the day that I'll fire myself. So last but not least, here's some spectacular imagery from the Solar Dynamics Observatory. This is actually 3 wavelengths, all ionized iron spectra. 211 angstroms, 193 angstroms, and 171 angstroms are the red, green, and blue, respectively, colors. And we'll zoom in a little bit to close things out. Once again, congratulations on realizing our channel exists. Welcome to the Neo Renaissance. Visit the links below our video and support the channel, please. We need your assistance. Share the content on your social media and tell your friends and foes. your science noobs and your science pros. And may that solar wind be at your back. Daily Space Weather videos brought to you at massive personal risk and expense from Smash News Network. Least busted name in news.